So if I ask you a question on a test or on a quiz, whatever it is, I say, okay, which of these structures has resonance structures? And if they do, draw them all. So let's look. Here's an example. Nitrate. Let's draw it. N, O, 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 and then there's a negative. We add 1. Okay. N is 5 valence. O is 6, 6, 6, and 6. You add them up, you get what? 24. Very well. How, what atom is central? N. O, O, O. Start with the outer atoms. Okay, and check. Do I have any leftover electrons? So far I have 8 plus 8 plus 8 is 24. So no leftover electrons. No leftover. So what do I need to do? Is N happy? No. So I need to what? I need a double bond. So now ask yourself, can I draw multiple structures where, I have the double bond shifting around? We're starting on the GenChem level. In organic, they're going to be much more involved. But for now, we just need a foundation here. So yes, you'll say, let's start with 1. So once again, start with 1. So yeah, so I'm going to take, let's say, this lone pair. And by the way, since we have a negative, we're going to need to put this in brackets, remember. Okay, I'm going to need more space here. So let me just draw this lower so you can see all 3 of them. Okay. So here's the double bond. Okay. Next. Can I draw another Lewis structure or a resonance structure, a contributor, where the double bond can be, somewhere else? Yes, let's say we can put it there. So watch the resonance arrows. Okay. Am I done, or can I draw, by the way, there's a negative here. Or can I draw a third one? Yes, we can draw a third one where the double bond is down there. So nitrate itself has resonance structures. It's always in resonance. There you go. Do I have a fourth one? No. I exhausted all of my options. So what would be the correct structure if I ask you on the test? You would say all 3 are in resonance, so they all describe the structure, the Lewis structure of nitrate. A hybrid would look like this if you were to draw it. You would have those dashed or dotted lines. Like that. Oh. Mm-hmm. So that would be the correct structure, or the hybrid. Be able to just determine how many you have or whether you have any, and if you have multiple, be able to recognize all of them. So let's look at an example. Let's say I ask you on a test or on a quiz or whatever it is, if a molecule has any resonance structures. So if I give you a structure such as, let's say, something like CBr4. Okay. If you draw this and we drew something similar to this, you would get this structure. Where, you know, they have lone pairs on each, 6 of them on each bromine. Okay. Question is, do you have any resonance structures? No, you don't have any. There you needed, you know, you had a double bond that had to be moved around. Here, there are no resonance structures. So there are no resonance structures. You cannot draw multiple. Basically, what I mean is, can you draw another equally plausible or possible, stable structure of CBr4? And the answer is no. There isn't another way you can draw this. What are you going to do? Put a double bond here? No, you already have an octet. So again, there's no resonance here whatsoever. Okay, well, what about something like SO2? Do I have any resonance structures? Well, let's see. SO2 would come out to be like this. So can I draw another resonance structure? Yes, you can put the switch, you put the double bond now there. So correct. So you do have resonance structures. You have 2 of them. What about here? And let me just move this. Well, we'll just move down a little bit here. Okay, that's enough. What about something like this? Do I have any resonance structures here? What do you think? Yes, I can switch this double bond there. So again, we're just beginning. Make sure you recognize, make sure you be able to draw the multiple resonance structures. Trust me, you will know how many you need. Basically, here I noted only 2 because I'm switching between these 2 bonds, etc. So yes, you do have resonance structures here. So that's resonance for you. be able to recognize when it's in a molecule, be able to draw multiple ones. And if you're asked, well, what's the correct structure, you would say all of them.